Tim Morgan. I have been a pen tester for the last 10 years, and prior to that, I've done work in systems administration, web development, all over the place. I've also done incident response work. I have a computer science background, and about this time last year, I started my own company. So it seemed like everybody was doing it. It'd be a good idea. So now that I've been doing this for 10 years, it's one of these milestones that makes you feel old, and you start to think, you reminisce a bit about how things were back then, when you started, and how software was different, and the kinds of issues that we ran into back then, and how some no longer exist, but for some reason some of them just persist, and we keep having the same problems. And so, the question comes up, do you think software security is getting better? Do you think we're actually improving the state of things? The software that we use every day, whether that be on our phones, or on our desktops, websites, do you think overall it's actually more secure than it was 10 years ago? Yes. Okay. So on one hand, I think operating systems are better. Like a lot of the code that we really rely on a lot, that has been around a long time, is getting better. We're doing a lot of things to mitigate attacks. We're fixing a lot of serious bugs. But at the same time, we're writing more software every year, and we're inventing new technologies. And the security folks are playing catch up forever with those new technologies. Sort of by definition, whenever somebody invents some new cool thing, the security guys, first of all, aren't maybe familiar with the technology up front, and second of all, we're not really sure how people are really going to use it, right? This whole Internet of Things thing, what the hell does that mean, right? It's just a collection of stuff that people are going to use somehow, but we don't know how they're using it yet. And if we don't know that, we can't actually figure out where the security issues are. So we're always playing catch up with the new stuff that's coming out, and that will always be the case. And every year we're producing more software than we did the previous year, right? Do we have enough security people to keep an eye on all of it? I don't think we do. So at best, I think we're running in place, and more likely than not, we're actually getting worse. I think. I'm usually optimistic, so that's, that means something. So here's just a little picture to kind of illustrate. It's a bit fuzzy, I guess. If I can zoom in any. So we have a big pile of code, right? We have a ton of code in production. And that code has a lot of bugs. And those bugs we don't know about, right? We don't know that they're there. We know they're there, but we don't know what they are. And every year we write more code, and that code also has more bugs. In our development community, we have a bunch of coders out there, and that, some of them are a little more seasoned than others. Some write a little bit better code than others. Some know about security, some don't. And over time, the more experienced developers, tend to start writing better code. Now I can actually zoom a little bit if I need to. So what is the coping mechanism here, right? We know we've got a lot of bugs, so we want to go look for them. So we do security testing. We try to simulate attacks, we do code reviews, and we try to find vulnerabilities, and throughout that process, we're working with the developers, right? We find the bugs, we explain to them why it's a vulnerability, we try to educate them, and that does do some good, okay? So here we are, pen testers, a very small community compared to the developer community, but we're going out there and we're finding bugs in key software, the software we think is important, and we're squashing them, we're killing those bugs. And at the same time, we're kind of maybe educating the developer pool a little bit, just by doing the pen test. I'm not talking about doing training, right? So it has some effect, and that's good. But I mean, very quickly when you get into this business, you realize that squashing bugs one at a time is not a very effective use of your time. Okay, like going after the next cross-site scripting bug. Okay, we've been doing that for over 10 years, and every app still has cross-site scripting bugs. So we really need to do better than this. So of course we also we're missing a lot of bugs in old code. There's a lot of really bad bugs that we have not yet found in code that was written 20 years ago. We don't even understand how that stuff works anymore. The developers who wrote it aren't around anymore. I mean, look at shell shock. That was around 20 years. Bash had that feature, and CGIs existed 20 years ago. Okay? And WinShock is almost as bad. That was 10 years old. And we've been using the Windows SSL stack how long? Right? So we haven't caught up with the old code, let alone be able to keep up with the new vulnerabilities that are coming out every year. So, I mean, it is actually a pretty bleak scenario right now.
So why are we only focused on number of bugs, right? Because architecture is also interesting, so there's bugs that don't necessarily...
That maybe aren't exploitable? You mean because of the nature of the architecture?
Yeah.
Sure. Yeah. I agree. And you know, in a lot of cases, those are mitigations that don't necessarily eliminate all exploitability. But I think in new technologies, a lot of times we can't anticipate how to architect things in a way that avoids them either. Does that make sense? It seems like a lot of the architecture changes we're making to avoid exploitability are in old architectures. They are in old technologies, right? Like ASLR and that kind of stuff. Like, see what I'm saying?
Yeah, I think I don't agree with you guys. So,
Okay.
Yeah.
Maybe it'll make more sense in another context after I get further. So fine. So what else do we do? We also try to educate developers, right? We also try to help them understand what the pitfalls are of programming, what to avoid. And we do this in colleges somewhat, and universities somewhat, although I think we can do a whole lot better than we are right now. I think most computer science students, for instance, that are in school, there may be security classes available to them, but usually they're an elective. There's the whole idea of avoiding vulnerabilities in your core classes doesn't seem to be there. I'm sure it varies a lot from school to school, but at least when I went through both undergrad and grad school, it just wasn't integrated into the program at all, where I've been. So, and then when it comes to sort of industry training, things like OWASP, SANS, and so on, those are very useful, and I think this is very valuable. But the problem here is that we can only train so many people, and we can only train them so fast. And over time, that active developer pool may become a little bit more seasoned, maybe a little bit better about not making mistakes when they write code. But every year, we have new coders coming in. We have new people coming in from university that may not be trained well there in terms of avoiding vulnerabilities. But you got to keep in mind, there's a lot of people who get in development who do not have a computer science background. Right? They come from, maybe they started as a designer, maybe they started doing JavaScript, and then they moved in to start doing server-side and client-side code, maybe mobile code. And so there's always going to be a significant number of developers who don't have much security training. And it doesn't matter how much we train, how much we throw at, let's say, free OWASP training and so on. There just won't be a significant, we're not going to be able to cover everybody, basically. And every year we lose people, right? People go into management, people who may be good coders who avoid vulnerabilities. They may go into management, they go into sales, they go into some other discipline. Okay, so there's kind of an equilibrium here, and so the training can only go so far, basically. I think I already covered all that. So my two assertions here, and you may not agree with them, okay, but my beliefs are that the development community is releasing vulnerabilities faster than security auditors can find them and fix them, right? Faster than we can fix them after the fact. Okay, so that's not a good situation. And no matter how much training we give, both in say, university early on, and also after they're already out coding, there's always going to be a significant ratio of developers who have very little security background. They've never got that training. They've never understood really what a cross-site scripting bug means. They don't really understand the reason why SQL injection happens and so on. There's always going to be a big chunk of them. And even if we get that number down to something like 20 or 30%, that's still 20 or 30% of code that's going to be bad. And you are going to be using it tomorrow. It's going to be in some app that you use, right? It's all over the place. So, and I guess one other point that I want to make about this is that, about the pen testing that I forgot to make, and I think it's important, is that a lot of times when we do security testing, we're focusing on the important code, right? Like, we're building a web application that has really sensitive information, social security numbers, account numbers, and so on. So guys like me get hired to go test that out, right? And when we do those tests, it's very much compartmentalized to that particular application because we can't test everything. We don't have enough people to test everything. But the way that we scope those kinds of projects rarely takes into account the way that that application can be affected by external code vulnerabilities. And that's kind of the shell shock thing, right? Who would have thought Bash would have caused a web vulnerability, a remote web vulnerability in hundreds of applications, right? Like, it's a shell, okay? And it's just a parsing bug in the way that functions were parsed. It wasn't even something where it interacted with a network or interacted with anything else. So the way that we actually focus in on the testing on a particular area is actually flawed. And we actually do need to eliminate the bugs everywhere. Even if we didn't know they were going to be there to begin with, we need to find a way to get rid of them before we have to test for them, if that makes sense. Okay, so what if we could build better platforms? What if we could build better environments for developers to where they're much less likely to have security problems to begin with? Okay. Now we've seen this happen before. This is actually very effective. So when people made that transition from unmanaged code to managed code, say from C++ onto Java, there's several whole categories of vulnerabilities that just simply disappeared, right? Your buffer overflows, your integer overflows, string format vulnerabilities, and so on. All of the things that could allow you to corrupt your memory, they disappeared overnight. As soon as you switched platforms, they were gone. Okay. So that's a really dramatic shift. And even now, just in the last 4 or 5 years, I've seen the number of SQL injection vulnerabilities drop pretty dramatically in new applications. Now, of course, you're still finding them all the time in old applications, but stuff, when you're using a modern framework for interacting with a database, you don't tend to find all that many SQL injection vulnerabilities anymore. It's actually fairly rare. So something is starting to work in that one particular area, but at the same time, we're replacing those problems with new problems. Okay? So we still aren't really able to keep up in my mind. But are there things we can do that would allow us, to change existing development environments without forcing developers to move to a whole new platform that could actually nip a lot of issues in the bud early on? And the developers don't need to be educated to do this. They don't need to understand why maybe this API changed or whatever. Are there things we can do to change the platforms to make them safer by default? And I think it's to point out that a lot of times when people focus on trying to make maybe language lawyers, people who do a lot of programming language work, if they're trying to create languages that are provably secure, they tend to take pretty major overhaul approaches, right? Like, let's build something from the ground up that's never going to have vulnerabilities, and it's usually not practical and nobody wants to use it. The key is, are there small, modest changes we can make to platforms that would actually fix things, so would actually prevent issues? And what are those small things? So what properties do security-conscious APIs exhibit? So if you're going to present some sort of API, and I use the term API in a very broad sense, it's just the set of function calls, the set of classes that you're offering to a developer to accomplish a particular task. What properties do those APIs exhibit? So let's take an exploration through counterexamples. Let's look at APIs that suck, and ones that are clearly bad, and it's pretty hard to argue that they're good. And then from that, try to decide what can we do to fix them, and maybe we'll learn something from that. So the first guinea pig I have on this is filter injection issues in LDAP. So basically, if you're not familiar with LDAP filter injection, this is a pretty classic bug. It's very similar to SQL injection. Whenever you have a developer that wants to run an LDAP filter and basically look for objects within the LDAP directory, they can use this expression where, I guess, get my mouse out again, where you can construct a query based on, if this property equals this, and then if it's in this particular class, then it will retrieve the object, right? So it's very, very similar concept to a SQL query, a select query. And the vulnerability, of course, shows up whenever you allow dynamic user-controlled data to get injected into that query. So if you take data from a URL parameter and shove it in to this username field, then the attacker can actually insert parentheses and change the logic of that filter expression. Okay? As it turns out, you can use this to actually brute force the values of properties on user objects. So against much older LDAP servers, for instance, directory servers, you actually can brute force the password hash of the user object. And the way you do that on, let's say, a login form is you just inject something like this where user password equals A star, which is a wildcard for the query, and then you iterate over all values of the first character, and then you move on to the next, and so on. You can work your way through it. So, LDAP filter injection isn't the worst bug that ever happened. Usually it's not exploitable for a lot. You can basically steal properties off of objects, extract data you should not have had access to, but it's not nearly as bad as a SQL injection. But it's been known for a long time, right? It was first described in detail. This is the earliest paper I found by Sasha Faust in 2002. So let's take a look at Adobe's Cold Fusion LDAP API. They offer the CF LDAP tag. I guess I should back up. So in order to avoid injection, what do? You should encode, right? Normally, the way to fix injections is to encode. Yes, you can also do input validation, and that's a good idea, but encoding is the correct fix, okay? To properly encode, in LDAP, you actually just do a backslash followed by the hex digits of the character. That's the standard way of doing it. It's in the RFC. It's all very straightforward. And so that would be pretty easy for developers to implement that. But if they're unaware that this is a problem, then that's a problem. So in Adobe's API, there's actually no function provided that does that escaping. There's just no function for it. It's not in the API. Also, there's no mention in the API documentation that there is any risk of filter injection. Like there's nothing describing that, oh, watch out for this. They do mention special characters, I believe, in one of the pages. But there's really little attention drawn to the fact that there could be a risk here. So you have to imagine most developers are not LDAP experts. Okay? How many people deal with LDAP every day? It's usually system administrators. And the one thing developers need to do when they interact with LDAP is they need to do that login form. That is what they do. I mean, for the most part, most developers, they need to interact with Active Directory or another directory server, and they do it and they move on, right? So they're not LDAP experts. You can't expect them to understand what the risks are here. But it gets worse. On Cold Fusion's CF LDAP page, they have example code, and that example code is vulnerable. So
that's beautiful.
Yeah, so I mean, this is just copy and pastable code. You just change a couple of things to make it work for your app, and it just takes the value straight from the form and shoves it straight into the filter expression. So let's look at PHPs. They do slightly better. PHP offers the LDAP search function, has filter capabilities, same sort of thing. They do offer the LDAP escape function. They actually have a function for escaping in that syntax. However, there's no mention of filter injection risks on any of the pages. There's no security discussion at all. I don't believe there's even a security discussion in the billions of user comments at the bottom of the pages. On the LDAP search page, there's also no mention of, oh, by the way, if you have special characters, go use this function. So, you've got like 30 LDAP functions over here on the left pane. If you're just looking at LDAP search, it's not going to be immediately obvious to you that you need to know about this escaping function either. Okay? But at least they have the function. But then again, their example code is almost as vulnerable. In the PHP example, they don't actually show you drawing the variable directly from the get or the post, right? They don't actually show you pulling it from the form. They just say person is all or part of a person's name. That's all they tell you. And then they give you example code of how to shove that directly into the filter, and they don't actually run an escape routine on it first. So the vast majority of developers are surely going to shoot themselves in the foot if they're just pulling from these examples and they don't use any other references, right? So it's pretty clear that we can improve these by fixing the documentation, mention security risks, and correct the example code, and all that kind of thing. But do you think that's enough? Do you think that would actually prevent a fairly novice developer from making this mistake most of the time? People are going to shoot themselves in the foot at some point. There's always going to be some fraction of them that make mistakes. But do you think a novice developer would, generally, do you think that would be enough to avoid the issue? I don't.
First step.
What's that?
It's a good first step.
It is a good first step, yeah. It definitely is a good first step. And most platforms, like say the PHP folks or the Cold Fusion folks, if you tell them this is a problem, that's probably what they'll do. They'll update the docs, they'll maybe add a filter function if they don't have one, and then they'll stop there, right? But I don't think this is nearly enough, because we saw this exact same thing happen with SQL injection, right? We've been dealing with SQL injection for a long time, and in APIs where all it does is offer you, here's the escape function, be careful, go. People don't actually do it right. They fail to encode a couple of inputs, think, oh, I thought that one was validated in another function. Oh, it's just too complicated to get it all right in every case. So what do we do with SQL injection? How do we actually, how do we deal with this problem? So the fact that calling escape functions manually on each dynamic input, it actually creates a little bit more work for the developer each time. Okay? And anytime you have a situation where you're creating a little more work to do the secure thing, that's a problem. Okay? They're much more likely to skip it. They get busy, 12-hour coding binge, whatever. And you can't, we would really love it if developers actually read the manual, but you have to realize the reality is that they won't. Okay, they're going to read the minimum amount of information necessary to get their job done. And usually that's just a function prototype. Okay, you just look at the function, you see the variable names, oh, it's pretty clear I should shove that there. Okay, go. Okay, that's usually what happens. And you have to understand also that maybe a lot of developers, English may not be their first language, and all the docs are in English. You know, there's a lot of reasons why people won't actually understand everything in that web page. Okay? So, APIs that actually help you do things safely in the most intuitive way, don't require additional effort, are ones that are actually good. And examples of that in the case of SQL queries are auto-escaping syntax templates, which is a more general term for parameterized prepared statements, right? And also more abstract APIs, which I think more recently, the more abstract APIs are the reason why SQL injection is actually going away. So if we're talking about object relational mappings, these are cases where you define your data structures, you'd say, I want to store this kind of info, this is how it's going to relate to each other, and then go. And the API just does the SQL for you, right? Those are APIs that just auto-escape everything, you don't have to think about it. And that tends to eliminate the issue. So if we were to fix the PHP version of this API, one way to do it would be to try to offer a parameterized query type of situation where we offer a query template in one parameter, and then we say, here, now you put your array of dynamic values in another, and then it just auto-encodes, right? The nice thing about this approach for the API vendor is that it's really easy to implement. It just takes a really thin wrapper around the existing code to make it work. It's also nice for the developer in the sense that if they already know how LDAP filter expressions work, then they don't have to really learn anything new. It's pretty obvious how the templating syntax works, and they can still use all of the same, it's all just as flexible as it used to be. They can do anything they want to with that particular syntax that they used to be able to do. One problem though is, and I'm sure anybody who's looked at enough other people's code will realize that you can still shoot yourself in the foot with this, right? So sometimes developers will actually dynamically generate their template, okay? And that's when issues come up. So maybe it's not perfect in a security sense. And so here's what, in PHP an abstract API might look like. So in this case, basically what we're showing is just that the developer might provide a set of name-value pairs for the filters that they want to put in there and how they want to filter the object down, and then this hypothetical LDAP lookup function would then just generate the filter expression itself. The caller never has to see any syntax, right? They never actually have to see any of the filter syntax themselves, and everything's auto-encoded. So this is similar to like the SQL ORMs. The problem with this approach is that it takes a little more work for the API maintainer to invent this new abstract API. They have to take everything that's in that language and sort of abstract it somehow. And also the developers, that's a new API they have to learn now. It's much different than the old one if they knew the old one. But I think it is sort of much more fail-safe. It's much less likely a developer will actually have a vulnerability here. So we looked at a number of other APIs. The Apache Foundation, they have a directory project, and that's a Java, LDAP, I guess, implementation. And then we looked at .NET, one of the Python libraries and one of the Perl libraries. And basically across the board, most of the major APIs never bothered to mention any security impacts of filter injections. Okay? And Python did, but their documentation overall kind of sucks. It's better than RS, and they actually provide a filter template. They actually provide a way to do filter templates, and they were the only one that did. And they also provide an encoding function if you want to do it manually. And then the Perl guys, they have a really big page with a bunch of documentation, and there's like a one-liner this long that, oh, by the way, don't let injections happen. So, I mean, yes, they said it. All of them can be improved a lot, right? So anyway, I mean, it's pretty. I mean, these issues have been around for a really long time. We've known about them for a long time. And consider a developer who just graduated with an undergrad degree in computer science, and is now, let's say, 24 years old, okay, and is coding. When that filter injection paper came out on what the dangers are of LDAP filter injection, how old was that person? 11. Okay, right. This, for some of us, this is old hat, and we all known about it. But this stuff is all new to the new people. So why don't we codify those lessons into the API that we've already learned, right? And so LDAP, it's just one corner case. It's just one API that is problematic. But there's tons of them out there. And anytime you're dealing with a syntax that developers have to interact with, and an API that lets them play with that syntax, you have the potential for injection, and these same solutions can work, right? So how can we generalize some of these ideas further? Are there some underlying principles that we could draw from this that would allow us to improve other types of APIs? Maybe not just in the context of injection attacks, but maybe also in the context of authorization issues, in the context of cryptography problems, and in other contexts like that. And I'm struggling with this, honestly. I mean, I'm trying to come up with kind of an overarching principle that says, well, if your API has this or these properties, then most likely it will be, unlikely for the developer to make foolish mistakes. They might make clever mistakes and be vulnerable, but hopefully they won't, make really easy ones to fix. So this is that sort of mission statement. I don't know if it's good. Maybe you can help me improve it. But if the most obvious way to do something with your API happens to be the secure way, or maybe replace obvious with if the path of least resistance is to do it the safe way, then that's going to be that's how people will tend to do it, right? So in the case of doing dynamically constructed SQL queries, even if you give them the escaping function and they have to call the escaping function on each element manually, that's more resistance, that's more effort. Whereas using a filter, using a template, then it's intuitive. It's not any extra work, and the encoding happens automatically, right? The code's cleaner, it looks better. Does this anyone have any comments on this? Do you think this is a good way to state it? Do you think there's maybe a better way to state it?
I think you're a little correction there. Replacing obvious with the path that we replaced the resistance.
Yeah, but and I agree. I mean, I think that may be more correct in most situations, but there's also that issue of that just obvious, like calling out the obvious aspect is important because people don't read the manual, right? So that the API standing on its own needs to be obvious to use it this way, and that is the secure way, right? So I'd like to capture both, basically.
But shouldn't the obvious be the path of least resistance?
Sometimes, maybe sometimes they aren't the same.
Maybe just the wording the easiest implementation or something.
I think it'd be a combination of, there are some developers together who are, experiencing the environment, they've been there for a while, they're turning out a ton of code, and at that point they're path of least resistance. But, you also have the camp developers who are new, or junior, or, they work on much simpler apps and all, right? Something more complicated, and they're just trying to figure out how do I get this thing done with some guy doing it, or, build it. So I think that it's obvious is definitely in those junior developers who can't get their security advice to them yet. I think obvious is actually center.
Yeah, and it's probably largely a matter of perspective, sort of as you point out. So for those of us who are more experienced at development, maybe what's obvious to us is very different than what's obvious to someone else. But I think we do need to focus on that junior developer, right? We need to focus on the folks that don't have the security background. And it's important that when you're changing an API or proposing that you change the way an API works, you're not going to take away functionality from the guy who knows what he's doing. You're simply making the safe way the fastest way to get it done. If you need to go around that, then still keep that around, because you don't want people, putting the brakes on you because, oh, well, I want to be able to do that crazy SQL query, and I know how to do it safely, So you don't want to take away functionality while you're doing this, but at the same time, provide a more abstract interface that makes it very easy to do the most common tasks, and those happen to be safe too, right? But yeah, so many APIs are basically written by experts for experts, right? And that's really true right now, like cryptography APIs. So the vast majority of them are just, they're for cryptographers by cryptographers, and you should already know what you're doing. If you go and just encrypt something with AES and CBC mode, you know that needs integrity protection clearly because you're a crypto expert, right? But nobody knows that, and therefore we have a ton of categorical flaws. okay, so we've got it solved, right? We know what we ought to do, maybe, or we could probably work it out in 5 minutes, right, between us. But how do we actually convince the vendors to make any changes? You know, so if I go to Adobe, if I go to the PHP folks and say, look, you know, I really think you ought to make these changes in this way, and this will make it much less likely that your customers will make mistakes. Maybe they'll believe me. Maybe they'll say, yeah, okay, that kind of makes sense. That's gonna involve investment on our part. That's gonna involve changes to the way our customers use the code. They're gonna have to update their code to work with a new API or a modified API. So there's a lot of effort involved in this. So how can we actually be convincing that the changes we're proposing really will work? Like, how do we know that it really will work? I think, you know, if you've looked at enough other people's code, when you're talking about something like SQL injection, you really do know over time that, yeah, you know what works, you kind of know what doesn't work, but it's still very case study oriented, right? It's anecdotal. We don't have numbers on this.
Do we not have numbers on the amount of SQL injection bugs publicly reported 10 years ago versus today? And how that works?
Yeah, I don't know that we have very good numbers. What we really need is numbers that say, okay, here's a set of developers that were using an older API that sucked, and here's a set of developers that was using a newer API, and how many bugs did we find in each?
Right, yeah, I don't accept that's clear, but I mean, one was applied by the other. I mean, it's pretty clear that everybody's using program squares right now, right? Unless you're loading by the last KSD, which doesn't support it, then you're almost forced to do it. Right? So you do have these, 10 years ago, we didn't have that, and we stat that, and today it's a lot easier because it's really hard to shoot yourself in the foot. So I think it's relatively easy to make that connection.
Right. I mean, to me, I'm convinced.
So I think that would be the perfect case, right?
Mm-hmm. Yeah, I think it is a really good example of how we've succeeded in one area, and we just need to apply the lesson elsewhere. But vendors, okay? I don't know how much you've had to deal with vulnerability reporting with vendors, but even just getting them to fix a bug in their own code can be a major challenge. Trying to convince them to fix something so that their customers won't mess up, like that's a completely new level, right? So we need to have a good argument. We need to actually have some data or some sort of way to show that this is really going to work. So I mean, one step we could take is actually standardize this. Try to come up with a way to say, here are some guidelines on when you're designing an API, when you're designing an interface for other programmers, these are the things you ought to do to avoid problems. And if we actually had some kind of security community consensus on this, we had enough people working on it that, you know, have reputations, then maybe that would carry some weight. And, you know, an API, like a security guide like this, not only could help influence the likes of major vendors, but it could also guide developers who are just building APIs internally for their own, you know, internal use, right? For different development, between development teams within an organization. So there's value beyond just this argumentative aspect. But of course, I mean, maybe the first thing you think about when it comes to OWASP and APIs is SAPI. You know, what about that? We haven't already like tried this sort of. Well, SAPI is a lot different, right? Because SAPI is trying to build an API that you want to use, right? It's a new API, and you're asking developers in various platforms to stop using what they're using now and go use SAPI to accomplish a lot of tasks, which is not necessarily bad, and I'm not against that. But it's a whole other step, and in a sense, you're asking them to do more work. You're adding new dependency to their framework, to their development process. You know, maybe a SAPI isn't the nicest for some things. And to me, if a developer knows enough to go look for a SAPI and integrate it in their code, then they're probably not that developer we're targeting, right? The developer we're going after is the person who doesn't know that the stuff even exists, okay? That a SAPI even exists, that OWASP even exists. I'm still floored by the number of developers who've never heard of OWASP. There's a lot. There is. So it's really key to get those changes actually into the platforms, the main major platforms, and make those changes there. Because that's what people will use. They're going to use what's available to them first. Making them take an extra step isn't going to work real well. But even a published standard may not be very convincing, right? So as we were just discussing, what would be really cool is if once we had some sort of a set of standards or things that we thought this is what an API ought to look like if it's safe, and that could be in a variety of areas, right? Then maybe we could actually do like a scientific trial. Go grab a bunch of undergrads who maybe have a couple years of experience coding, sit them down in front of two APIs that are almost identical except one's the unsafe, one's the safe, and see where the bugs are. See where the bugs come up. involve the university in the process, and then maybe we could actually have a good, proper study to show how much of an effect it has. That would be really nice. That's sort of the ideal way to prove it. But that does require a lot of effort and money. So, I don't think I'm ready to jump into that quite yet. But I want to get the thinking out there on what we could do as OWASP, basically, to improve the situation. I know there's a lot of effort going into ramping up more education efforts, more slide decks within OWASP that are free in order to help security training. I think all that's awesome. We need to continue doing it. But at the same time, I think fixing APIs is far cheaper. It's far cheaper and easier to fix the APIs in the core platforms than it is to have to go educate every new developer every year. So I think I've probably covered everything here a few times. Yeah, so basically this is an odd talk for me because normally I'm talking about very, very technical things and not the big picture. But this is a way to kick off kind of getting some folks maybe interested in the thoughts of how we could tackle this and how we can make a really good case to various vendors. And so if you're interested in this area, I'd love to chat with you, and maybe we can come up with some more ideas on how to move forward with it. So I'm ready for questions or other thoughts. I also have a few blog posts on this topic, and I'm going to keep blogging about it for a while until I've said everything I have to say. So feel free to contact me offline as well. But anyway, questions? Thoughts?
On the migration path, once you come up with new APIs that are more secure, it might be a good idea to think about tools that would help you to really recognize the places where you need to upgrade to the new API. Automated tools. It wouldn't actually do it for you, but point out, here are the 1,200 places we've used this API before. Here's something that will just help you switch to the new one. Something that might, maybe an OWASP project.
Yeah, that would be really nice. I mean, if we got to a situation where we actually convinced some vendors to really change their APIs, then a nice tool, for that particular platform.
Because that would be a boundary to moving large organizations from existing code to more secure.
Sure. Yep, definitely.
I think the big one would be just JSP. Just for XSS detecting phenomena. Figuring out how to make JSP work.
Yeah, I mean, I think with a lot of servers in the Java land, I think you can enable decoding by default, right? With some of the include tags. So that didn't used to be the case, but I think that's a big step in the right direction, and it is kind of it's one of those secure by default kind of ideas applied to this area. I don't know what other ideas you have beyond that.
Oh, for you guys to work on?
Or no, just like how else to improve JSP in that sense with cross-site scripting.
But what we had that was just just print use call function and print it, and there's nothing there. That seems to be one of the more common ways to
yeah. Right, and so then I guess it comes down to, okay, if you're going to do like whatever, I'm trying to remember the syntax, percent equals or whatever to include a variable, right, and it auto encodes, is that, how do you make that the much easier way to do it than print, right? So how do you encourage people to use that rather than print? And yeah, it'd be an interesting area to try to figure that out, at a technical level, but I don't have any answers.
I think one of the places that you could definitely try different types of approaches, which are internal APIs. You do have, depending on the company, full control over, and at least some control over what you can do there.
Right.
So you can use that as your test bed. I don't have any ideas on how to do it, but
you probably get traction faster there too. When people are trying to build something,
I guess if you had a situation where, perhaps one group within an organization was building a set of central code, and then you had lots of other apps relying on it, making the change and building, perhaps in the midst of building a new app, how did that compare to the older apps?
And then you could definitely get feedback from the developers who are actually using it and say, hey, how come you're not using this one? And, you know, they'll give you feedback. This sucks.
Right, right. Yeah, that's a good idea.
I think just kind of anecdotally, I feel like solving the documentation problem. Like if you think about it, so you propose like there's kind of three problem areas. There's the documentation problem, there's the user education problem, and there's the API itself. So I think like those three things being the master solution to this whole big area problem. I think the first part is the kind of the easier one to solve. The most ROI in my opinion is on solving that documentation problem. So think about like user, students straight out of college wants to know how to use like fixing technology. What do? They Google how do I use this, and they find some stack exchange post.
Yeah.
Or with any luck, they end up on the GitHub page that has some example code. So just really solve like that documentation problem, where documentation is just like the stuff that the vendor provides per se, or just like the community information out there. I feel like that's that could be. But I feel like solving that problem is easier than solving the API problem. You can like get things going much quicker if you solve it.
Yeah, well, I agree it is easy to, well, in one sense it is easy to fix that problem now. Clearly it's easy to update those web pages that have vulnerable code and so on. But just as you just pointed out, people Google and they get the Stack Exchange stuff. Okay, so which one are they going to use first? Which one had code that was closer to what they're trying to do? And you have no control over the Stack Exchange one, right? So you can fix the docs here, but if they don't pay attention to those.
Yeah, it's kind of like a leaky dam, and the source of the leaky dam is that original documentation, and the Stack Exchange is where this crap that's spilled out along kind of goes. So you can plug the original source, but maybe
Over many years.
many years, then it'll go away.
So here's what happens. The young people, they just go and Google things and, oh, look, I found some crappy code and I'll copy and paste it. Okay, that happens because crappy code works. And crappy code that just works happens when you have a loose system that is permissive about what it'll allow, like PHP, and then someone else goes and builds a really tight, bitchy, very checky language that is no fun to program in because it's really hard to get your code to compile and actually run because it keeps giving you errors, and nobody likes it, and they'll go over to PHP and do it.
Like Java? Like Java?
I'm joking.
Well, somewhat. I mean, they are definitely on a different place in the spectrum in that respect.
Like Java wanted to be the browser scripting language, and it lost it completely to JavaScript, which is much more slack.
Right. Yeah. So I think that's a good point, and I'm not sure where you're going with that.
That life is hard. That problem is really hard because hydrogen is the second most common substance in the universe. Stupidity is number one.
Well, but so I guess what I'm trying to argue in how you would go about changing APIs or interfaces is not so much that you want to make it stricter and more difficult to use. You can do that, and that might help. If
You don't want to make it more difficult. It's just that by trying to make it stricter and more fail-safe and secure, as a side effect, it becomes more difficult to use.
I think
it's
that's
really hard to
sometimes
use the elegance of making it easy and secure.
I think that's sometimes true, but I think sometimes it's not true at all. So I think with some APIs, it's the devil's in the details. It's the little things that really matter. And when you make one little tweak, sometimes that just kind of nudges everybody in one direction. But it's not any harder to use. But in some cases, yes. Sometimes you have to do that validation, and then suddenly things are a pain, and you do type checking and whatever you're going to do, and then things become less fun. So I think sometimes it's true, sometimes it's not. I think the key is like having the attention to detail to actually figure out which cases are which, and try to do the best we can without making things harder and pushing people away from the platform, for instance. But it's a good point. Okay. I guess one other thing, since I think I have quite a bit of time left, is go ahead. Oh, we have 10 minutes left? Oh, am I supposed to be done now, or am I supposed to open it up to questions?
I want to give people time.
I switch. Oh, okay.
If I give people time to
Okay, so I'm done. All right. Feel free to plug me if you have anything else.
Are you gonna?
Yeah.
Okay.
What time is
Ride share?
well, I was gonna say,
I want to go there.
yeah, but I can.
Make the, exactly what you said, make it obvious, straightforward, and safe. But the other thing is that when you get people out of it.
You'll have a lot.
Oh, yeah,
I'm glad that-
And you probably.
So what's going on now?
Yeah, I can't imagine this stuff because the difference just what's going on now.
Well, I have to go.
Yeah.
The more you look at examples of good APIs and look at them.
But yeah, I was planning on just.
Oh, cool, wow.
We've got 1,800 engineers who know nothing at all about
Oh, wow, yeah.
And I think probably this whole conference, this is the one that I've been waiting for. I mean, it's got to find out to blow your or anything, but it's a lot of what the discussion is about. How to do this. It's really hard to do.
No, I don't know.
I mean, here, I'll send you this security box. Be very few about how to build things. And I think this is really one of the problems that we can solve. Will make the biggest impact.
Yeah.
Changing the events. It's just not possible to do the thing without them in the first place.
Yeah.
I've been a developer for 5 years now, and it started a mainframe. Mainframe always gets 60 was far more secure.
Stack part of the model, so
A
you're backing off.
lot of it because it's so local, you couldn't keep yourself with it.
Yeah.
Just if I can remember right.
Yeah, that's the problem.
Wow, you know, people will say it's more difficult. No, I don't think so. I think writing PL1 for mainframe is not very difficult. Easy language.
Yeah.
And then it's going to do a lot of damage that way. And it's become a lot of it because it's sort of fun culture, right? It just has to be fun.
Yeah.
How much fun is it to be an architect and build something, right? But they have to take into account safety, physics,
Yeah. Yeah.
Like, other people will die if this thing collapses. People will die if your software is sort of like
Yeah.
is ugly as well.
Yeah. No, I know.
I say, why are we still here to the fun crowd, right? It might be fun, like the guy on the team or whatever, but make it so the fun guys will get to decide on the infrastructure that's underlying